Okay, let's see. I guess I should. Oops. All right, I guess I'm not ready to go. Let's see here. All right, some things are all stretched. So yeah, while I work on these little technical difficulties, how are folks doing? I saw some of you in during office hours checking off milestone stuff. A lot of others I have not seen, so that's either a good thing, but in my experience it's a bad thing if you're not showing up. So yeah, how are folks doing? The ones I didn't see. Yeah.
Like I think a couple of us over here are using like the physics engine, like the Box 2D physics engine.
Okay.
Do you know any good places for documentation on it?
The only thing I could suggest, so I haven't used Box 2D myself. I would check to see the folks that are developing it. Do they have a forum? Do they have a wiki of some sort? But the other place is the Cocos 2D forum, to ask around there to see what folks have used it. So, what are some of the issues you're running into?
This is just learning it all, like just like kind of involved.
So I forgot, what were you?
I'm doing like a battle game.
Okay. Yes.
I'm working in the
Uh-huh.
They keep on saying don't deallocate objects like in the collision functions that you create.
Okay.
But they never say how to remove objects.
Again, it's another, this is the fun of 30 folks going off and doing all sorts of applications. You're going to go and use some things that I haven't used. The main thing, my thought is they'll probably have some sample applications that use it, and you can just kind of see how they do it. And again, probably, I don't know if Chipmunk has a forum of some sort, but there are folks on the Cocos 2D forum that have used it for sure. So I would ask there, say, hey, I'm a noob, I don't know. Make sure you've read through some of the documentation, because oftentimes, if you're sure you've gone through it and still don't have your answers, then go ahead and ask.
And that's like the one brick wall that I hit this week.
Okay. Well, you got 2 weeks to bust through that brick wall. So our apps are due in 2 weeks. So I'm looking forward to seeing. I've seen some good stuff in office hours during milestone checks. So I'm excited to see. You've got Thanksgiving after you get over your turkey coma to work on stuff. So
yeah, one thing everybody should realize is we basically have 2 weeks left.
Yeah, that's it.
This quarter. So that we kind of have to ramp things up here to get these apps done, because it's a little shocking to realize that it's a really funny quarter this year.
Yeah.
Really funny fall quarter. It ends really early.
So yeah, 2 weeks to do 5 weeks worth of stuff.
Yeah,
I'm sure you're all used to that kind of stuff, so don't worry, it'll be fine. Okay, so today I'm just gonna I'm gonna finish up some of the core data stuff just pretty quickly. Just gonna so we left off with this fetch result controller, and we sort of saw how it was used, but we didn't really see how it was set up. So we'll kind of just look at that, and then we will move on to the accelerometer, and it's probably one of the simplest APIs. So we'll just take a quick look at it, and then I'll run a demo here on the simulator, which the simulator doesn't really have accelerometer support, but I'll talk about how you can do some things if you have a device and you need to test, and you would prefer to test in the simulator for various reasons, how you can still use your device to actually test remotely and see things in the simulator. So, all right. do we all remember this thing? We saw it about.
We need to focus recently back here.
Oh,
Yeah.
I wonder.
Focus our projector.
Yeah, I don't know what that's about. I don't have any control over that. This thing was kind of dented up, but I managed to put it on. Let's see. Let me cycle this real quick and see if there's anything. Well, we're not going to spend too much time on slides today. I've got like 4 slides, so it's okay. But let's see.
There we go.
There we go. Perfect.
All right, push the button that was already pushed. Nice. Okay. So we all remember this thing. It's all perfect, crystal clear. We understand. Maybe not. I don't know. Okay, so we remember this thing, the core data stack, and that's what this image was meant to sort of show. So we had this persistent object store. Yeah, the store coordinator, this managed object context, and our managed object model, the MOM. So MOM was the thing we were setting up inside Interface Builder with that modeling tool where we set down a theater and a movie and we changed some properties on it. So that's where we were messing with some entities. I don't know, I guess before I go on, does anyone have any questions about some of the core data stuff? Like, is it clear yet why we would want to use it? No? Okay, I'll say no. So, I guess, one of the main things is it's meant to, it seems kind of harder to do modeling with it at this point because maybe we're just not that used to it, but it's meant to actually simplify your life. And once you really start using it, I think we'd probably all see how wonderful it is. So if we remember the entity stuff, I guess another analogy that I can make is entities are sort of like classes, where classes are a description of your object, and when you're actually ready to instantiate your object, you do an alloc on it. In this case, this managed object model, that is, that's sort of your class. You have this description, this template of some sort of data type. And yeah, when it's time to actually use or instantiate this object, you end up getting this NS managed object from the entity. So at the end of the day, it's, you have an object just as if you had allocated, had a class and allocated it in some way. And then you're supposed to be able to just manipulate it and do whatever it is you want to do with it. The main benefit being that when when you're ready to save this data off, you can just say save, and depending on how you've set up this persistent store, it'll either go off to an SQL-like database or some sort of binary file, or if you're doing something special where you need a memory-backed persistent store, which seems kind of funny to say memory-backed persistent store, but you could use that. So let's take a look at my preferences real quick. So this is just like the default example that it's like the default navigation controller that uses core data. So if we run it, we should just see a few clicks that I may have made to add some events, unless I did a build clean. We'll see. So this is sort of the default thing that comes up, and we can add. And so 16, 52, 13. So if we quit and come back in, all that data should be there. And it was all nicely, 16, 52, 13, nicely taken care of for us. So just again, as a quick review, we have these, these things that defined our stack that basically helped us set up all the core data things that we needed to set up. And I won't go through that all again. I guess you can trace through the code and see how all that stuff is set up. But where we left off was we were talking about this fetched results controller. And I think the thing I didn't really mention last time was that the fetched results controller is basically, it's this thing that's supposed to help you take data out of, say core data managed stuff and display it in a table view. So it just sort of helps make that process easy for you. So if you remember the example I was going through last week, it was basically, we saw that we had a bunch of, we had a bunch of our usual table view methods, and we saw that using that fetch results controller, we could just very easily ask it for, the things that we might need to put into a table. So I think what we didn't really look at was, well, how is that fetch results controller set up? And so, in terms of this view controller, we see our good old friend view did load, which we know is a good place to set up some things when the view loads. And in this case, a few simple things. Just let's get some sort of navigation bar button thing going, and in particular, so we're setting up an add button, which if we look back, each time we click add, it's placing another timestamp in one of the cells, and so we could edit and delete it. And if we look at this line here, this add button is basically saying, set up this add button. The target is ourself, and the action that we're going to run is this insert new object. And we'll take a look and see what that does in a second. And it actually goes ahead and assigns that button and frees up some memory. The next part is where things will get more interesting. So let me just hit a breakpoint there and start again. Managed object self. So this is part of the initial stack setup, which we went through last time. So setting up the persistent store and the managed object context and all that kind of good stuff. So now we're at this place, the view did load, where I was tracing through earlier. So let's just walk through. So we saw that add button, and so now I wanted to take a look at this fetch results controller. And what should happen is that should be a method that, if we step into, basically we'll see how the fetch results controller gets set up. And again, remember, the fetch results controller is just this thing that helps us manage the data from core data and displaying it in a table. And so we can just see how that all gets set up right here. So that first if, we haven't been allocated before, so let's actually go and allocate stuff. So the first thing we do is we set up this NS fetch request, and I don't think I mentioned it last time, but the fetch request is basically exactly what it sounds like, a fetch request. So it's this object that you can set up that you can give it various properties, or say a predicate of some sort, or some sort of regular expression that you can then ask you can ask core data. You can say, hey, here's my fetch request, and based on that fetch request, it's going to return you some set of objects. And so that's what we're doing here first. So we're setting up a fetch request. In this case, we're not really doing too much in terms of what we're giving it yet. the next thing is we're actually getting our an entity description. So if you remember, entity is our actual model, and that's the thing that we were setting up in that model in here, in this case. All right, so this was our entity, and so what we're saying is, hey, where'd you go? What we're saying is, give us the entity description for entity name event. So for all your entities, you give them some name. In this case, it was event. Maybe it's a person. Maybe it's a movie. Maybe it's a theater. Maybe it's an expense. So we ask it for that description, and we tell it, where is it that it's hanging out in. It lives in this managed object context that was set up earlier. And so we've got that entity, and now what we're doing is we're saying, our fetch request set entity. So now our fetch request knows, has a certain type of entity associated with it, and so maybe we know that doing a request against our data could return us tons and tons of objects. So what you can do with the fetch request is you can say, well, limit that to, say, 20 objects, and then behind the scenes, core data will take care of bringing in more data, say if you're kind of flying through a big list of stuff. So we've got a batch size. Next up, there is a sort descriptor, which again, I don't know, these names sound fairly descriptive. So in terms of the sort descriptor, you can say, how should the data that's returned to me be sorted? And in this case, it's saying, we're going to sort based on this timestamp value, which if we look at the default model from this example, if I could get back to it, we'll see that one of the attributes or one of its properties is the timestamp. And so we've got our sort descriptor. We need to package it up into this NS array. And then again, we give the fetch request a little bit more information. Now it also has this, so we've got this batch size, we've got this sort descriptor. You could also have some other things like some sort of a predicate, which this example doesn't do. But if you look through some of the other samples that Apple has, you'll see some predicates being used. Again, just to help you filter your data out in some way. And so, once you've got your fetch request, you can now go ahead and actually instantiate or allocate your fetch results controller, and you feed it your fetch request. You give it this managed object context, which, if you remember, the managed object context is this sort of scratchpad place where when you bring things in from core data from the persistent store, or if you create some new objects, they're hanging out in this managed object context, and you can manipulate them and do whatever you want to do with them, and discard them or actually save them. And when you save them, they'll move from this managed object context, or they'll get persisted. They'll go through the stack and eventually end up in this, they'll eventually end up in this file store. So remember, managed object context up here, our little collection of objects. So we set that up. We also tell the fetch result controller who our delegate is, and we're just assigning ourselves to be its delegate. And we'll go ahead and save a copy for ourselves, and then release that one, and just get clean up some memory. And so that was pretty much. That was sort of the last little bit that we had left last time, which was, so we kind of went backwards, which was let's look and see how this thing is used, and then today we finished up with looking at how it's actually allocated. And if you want, just real quick, we can see one of the more important methods when talking about tables in particular is the cell for row at index path. So if you remember, when you're scrolling through, as those cells fly by, you'll get some sort of an index that tells you where to get the data that you want to get. So we'll take a quick look here just to see. So some usual things that we've seen with cell for row at index path. There's actually creating that new cell that's just appearing on the table as, say, you're scrolling, and so again, some usual stuff where, in terms of trying to be more efficient, what Apple has done is they've set up this DQ reusable cell with identifier. So in reality, when you're looking on screen, maybe you've got 10 or 20 cells. So there's no reason to allocate 1,000 of them, because they're just going to kind of they're going to fly off screen anyway. So what this thing basically does is it just pulls things out of the queue. Once something flies off the table, it sort of kind of goes back towards the bottom. So we've seen that a bit, but the part that's interesting for us at the moment is how do we actually get the data to place into the cell. And so this is where we see the magic of this fetch results controller. Once everything's been set up, we just give it this index path, that cell for row at index path is sent, and we get this managed object, which, remember, the managed object is now it's an instantiated version of your entity. So it's so you have a class, you can instantiate it with alloc. You have an entity, you can get at it in this case through this fetch results controller. So we've got our object, and if you remember last time I mentioned, we talked about this key value coding stuff a bit, where we can ask any object for one of its properties via a string, and that's exactly what's going on here. So we've got our managed object, which is an object of So our NS managed object is an event object, and one of the attributes it has is this timestamp. Oops. Go. Has this timestamp, which in this case I guess is a date type, but right. So timestamp. And in this case, the timestamp, I think, is going to bring back some sort of, it's a date. It is some sort of a date type, and we're just asking for its description. Which, in this case, when we ask this particular type for its description, we end up getting the text that we see here, which is this 2009 11/20, basically the date information. So I think that's going to be it for core data. There are a ton of samples, some much more involved than others. The iPhone core data recipes one is very involved, but worth looking at in terms of seeing how data is passed around, and it does a lot of other things, including tab bar controllers that have navigation controllers inside them, and so all right, that's it for our good friend core data. Next up is the accelerometer. So for those that don't know, your iPhone has And iPod Touches have an accelerometer inside of them, and basically these things, the accelerometers just sense gravity, general device motion. So you know, you've seen how you can rotate your device, and once you rotate it, you know, the views will rotate, assuming some things have been set up. But the way that the application knows that that's happened is because of the accelerometer. So you can detect rotations, shake, tilt. You can tell whether you know, whether the device is facing up, whether it's on its side, whether it's facing down, any number of things. So this is one of the images out of some of the Apple docs, which gives you an idea of the accelerometer. So you actually have three. So you have X, Y, Z accelerometer information, and in this case, we're seeing that Z, you know, the device going in and out this way. So this is a right-handed coordinate system, and yeah, so we should see some stuff if we move up and down, forward and back, side to side. Now the issue is that, and I guess I could have used that camera, but it's not as fun. What you can do, the simulator doesn't have an accelerometer. These laptops actually do have accelerometers, but I don't think I would be too keen to, like, you know, try to do my simulator thing with this thing. Maybe when it got a little bit lighter I might, but so let's take a quick look at how to set up some things, and then we will look at a demo app, and then I will show you, for those of you that have devices that want to test in the simulator but using your device, I'll show you how to do that. It's pretty easy using some open source project, and we'll actually be using it in order to see what's going on here. So let's see. So this particular application, I'll just run it, and it won't do anything right now, but just so we can see what it's about. It's one of Apple's sample things, and basically on the top we'll get some accelerometer data flowing through, and then on the bottom it'll either be low pass or high pass filtered, and then you've got some different types of stuff. And for those of you who've taken more recent electrical engineering classes can tell me more about the adaptive versus the standard later. But we've all seen, presumably we've seen low pass, high pass filters. Low pass filters let low frequencies go through. High pass filters let, you know, they kill off low frequencies and let the high ones through. And we'll see that oftentimes the data that comes from here is very noisy, and you know, it'll, like, even we'll see when we run it, but even sitting on this table, it's very likely that, you know, there's these little vibrations and stuff, and maybe you want to filter some of those high frequency noises out to focus on sort of the bigger movements that are happening. So again, in terms of setting up the accelerometer, it's about, let's see here, well, our usual friend, the UI application delegate. In this case, we'll go to the controller where it's being used. So you adopt this delegate, this UI accelerometer delegate, and implement this method. And basically, this gives you the information that you need. And as far as the rest of the code in this class, a bunch of it is, you know, how do you draw these graphs and how do you set up everything else. We won't worry about that. We'll just look at this filter, which is the thing that takes care of our low pass and high pass filtering. We'll look at this delegate method here in a second, and we'll look at, just on startup, some things that go on. So for this view controller on view, well, you know, our usual place, view did load when we want to take care of some stuff before too many crazy things go on. We see that the accelerometer, well, we can get at it with using this method here. So UI accelerometer, shared accelerometer. So this is, you know, one of the good uses of the Singleton pattern, which a lot of people are sort of down on these days because it's getting used all the time for not necessarily good things. But basically, if you're not familiar with that pattern, it's just a way of saying or managing resources in a very specific way to say that there's only one of these things on the system. So in this case, it's saying, you know, I've got this accelerometer, and there's no need to create all sorts of, you know, tons of different objects, accelerometer objects. There's only just one, and if you need it, you can get through it by saying UA accelerometer, shared accelerometer. And in this case, what we're doing is saying, you know, set the update interval, which is basically, you know, how often you want to know that something's going on. And they're using this K update frequency, which they've set to 60. So basically, 60 frames a second of information of accelerometer data. Maybe you don't need it that often. If you don't, then you should lower that number and save some, actually, I don't know, maybe save some battery life. So we've set its update frequency, and then the next thing we do is we're setting a delegate to ourselves. And we saw that one method, you know, so the rest is just sort of, again, setting up some information or some things necessary for the application to run. But as far as the accelerometer is concerned, you know, pretty much good to go with that. And if we look at this delegate method, basically we get some information, and it's saying, okay, let's update the graph. So if we're not paused, we're going to take our filter and add some acceleration data to it. And so yeah, if it's not clear, the accelerometer, right, measures measures accelerations. So, you know, how many G's is something moving at? And so yeah, basically the accelerometer data comes in, and let's see. If we look at the accelerometer info, this UI acceleration object, basically we get a timestamp when something happened, and then we get these values, these XYZ values that represent the accelerations in the different directions. So that's kind of it, right? It's set up. Now we're just passing information to this filter. Let's take a quick look at the filter just to see what exactly it's doing. And basically we have a few properties. The acceleration value, these accelerometer values, which should be just doubles, which we saw here. And well, let's see. So then we, you know, they've set up a few interfaces here. So there's a low pass filter that's being set up, a high pass filter, and they all just inherit off of our accelerometer filter, and then just implement a different, a different filter, either low pass or high pass. So let's see at the top here. So we saw that when we were getting the accelerometer data, we were calling filter add acceleration and passing that UI accelerometer info or UI acceleration info in. In this case, it's just sort of saving it off. And let's see, actually. All right, so we had our filter add acceleration. So filter add acceleration, and yeah. So if we take a look through here, we'll see again a few actions. You know, pause, resume, turn something on, off. Choose either high or low pass filter, and whether it's adaptive or not adaptive. And oops, I wanted to be back here. So if we look through here, they have a few little functions set up for us. When actually creating the filters, so if you remember high pass filters or our filters, they have some sort of cutoff frequency. So basically they're just setting some constants that we're going to need to actually do the filtering. And basically when it's time to write some accelerometer code and you need to do some filtering, you jump to this sample and grab what you need to grab. and make sure you understand exactly what it's doing. If you need a refresher, there's always our good friend Wikipedia. And so let's see. So add acceleration. I guess the other one I was looking at was just a default one that did nothing, but yeah, basically we get our acceleration info, and if it's adaptive, we do some extra work to set some things up, and then just basically apply the filter. So I'm going to run this, and then I need to set up an IP address on here real quick, and then as soon as that works, we should see some accelerometer magic, some things happening. Just give me a sec to connect to MobileNet. MobileNet. Am I on MobileNet here? Yes.
What's the open source program that lets us use the accelerometer?
I will show it to you in just a second, because if I show it to you now, you guys will like set it up real quick, and then it'll mess with what I'm doing. So, because I haven't set there's some port settings, and I'm going to just broadcast versus doing a direct thing. All right, you guys can't see my password up here, right? Okay. Sorry. That's right. Stop listening to me type my password. All right, and if all works as according to plan, we should start seeing some stuff on there. So I'm going to zoom in a bit on it. What's that?
Your iPhone died.
No, it's just hanging out. Like, I don't know if you can. So it seems like it's getting sort of filtered out. You can kind of see a little bit, but just me moving it, right? You can see some dips. Just sitting on the table here, there's some small fluctuations.
So that would be the z-axis getting hit that orientation.
So let's see. So we knew it was set up as this right-handed coordinate system where z was, negative z was towards you for you OpenGLers out there. So sorry, this thing turned off. All right, so moving back and forward, we see that blue is probably our z. And then going this way, the green, so this is our y. And then our x is going to be our red. So if we look at the top, so the top is the unfiltered data. If you see this sort of pattern, you know that your user is trying to, they're shaking their device. Maybe if there's, I don't know, if you're doing like a spin the bottle type of app, I guess you might be able to tell. I don't know if you'd want to actually spin your app, your device. You probably have a little spinner inside, but it may be more interesting to spin your device. I don't know. So let's see. So I'll try and do some low frequency motions, and let's see if we put on the high pass filter, if it sort of. All right, if we see, I'm still sort of doing pretty much the same thing. So I'm trying to do, if I bring it back on, we should see more fluctuations. And now they kind of go away. So again, it depends. If you have an application where you want to track that a user's, doing something slow, then, or or you don't, you would want to filter that out, so you'd use the high pass filter to let the high frequencies through, and sort of these broader motions to kind of die away or get filtered away. Now, might be a situation, so let's see. So with the high frequency, so we see up top, right, we see very, we see these high peaks and valleys, and if we look down below where the filter's happening, we see that they've been cut off, or it seems like it has been, but it's actually because now it's just been looking at sort of the smaller motions, which again we can sort of get through. And let's see, adaptive should give us sort of nicer results because it's doing more work, right? So there's our low pass friend as I do my sine wave across, and then back to high pass. So we see now the high pass adaptive versus the standard. So there's the standard high pass, right? We're still getting a bunch of these low frequencies coming through. But as soon as we move over to this adaptive, it's pretty nice. And then, there's our high frequency stuff again, adaptive. If we go to the standard, they're still there, but yeah. So that's our accelerometer friend. So there's a lot of interesting things you can do with it. Folks are using it as game control type stuff. Some apps use it well, some use it just to use it. As usual, when it comes to interface, use what makes sense. Don't use something just to use it because it's there. This one's kind of fun. I don't know, I like it. The website to check out, well, so first of all, there's an application, and actually let me show you. There's an application that I'm running on here called Axim, and I'll show you the website in a second. But what you can also do is, oops, did something die? MobileNet kicked me off. Darn you, MobileNet. So I'm back on the 3G network, so I won't connect back. But there are some settings where you can override the accelerometer and actually choose the XYZ values. So again, if you're debugging something and you need to have some very specific accelerometer values come through, you can just sort of feed, set them up here, and or just sort of tweak with one of them. You'll get some values that aren't necessarily true accelerometer values, but let's see. So this is the site. That's on Google Code. If you just look for accelerometer simulator iPhone, this should be the first link. And it's pretty straightforward to use. And this is what I'm seeing on my screen. And then this setting. So you've got two things. You've got this broadcast and unicast. Broadcast was what I was doing. That's why I was telling you not to set it up, or because then you could mess with, you could take over my screen and stuff with it, I guess, which is fine. But so the broadcast might be appropriate for some of what you're doing. If you're noticing a lot of lag, you'll want to do the unicast. So once you do unicast, you can just give your IP address, and then you'll have just a direct connection instead of sending tons of packets out into the wild. And basically the way you end up using it, so first there's an iPhone application that you can build and install to your device, and then the second bit is there are these two files that come packaged with that code, and you just include them in your project. And so you include them in your project, and then in the place where you're setting up your accelerometer, in terms of the update frequency and the delegate stuff, basically you then just add an import and you're all done. And now you can communicate via UDP with your simulator through the iPhone. So it might be fun to look at that Google Code sample from who is it that wrote this? Otto Kranz. Kudos to Otto Kranz for having put this together. And yeah, it might be worth checking out just to see, how can I do some networking stuff with the device into the simulator, and yeah. So, all right, everyone, make sure you incorporate the accelerometer into your application, even if it makes no sense to do so.
What's the expense we're going to do with an accelerometer?
Yeah. No.
So it will automatically balance both for you?
No, when you shake it, the sound that you hear is based on how much money you have left for that month. So if it's like loud, then you've got plenty of cash. If not, then you don't.
But every time I save it, you shake it, it'll make a lot of sound.
Yes. So okay, that's all I've got for today. I'll stick around for the next 30 minutes or so if anyone needs me to. We can talk about some stuff or not. We can just sit here and yeah. So okay, thank you.